Good afternoon, people. So, we're going to be recording this class just to see where we go with it. This course is TEQU 422, and it's about process control. And what we have today is trying to understand how can we get the input data into the Arduino controller. Like, for example, we know that our Arduino is basically something like this, in where it has inputs or output that are 0, 1, 2, 3, 4, 5, and so up to 13. And these are defined either as inputs or outputs. It all depends on the pin mode. We decide what pin mode we're going to be using in the Arduino, and so we have the proper setting. Like, for example, if we want pin 2 to be an output, what we have to say in the voice setup of the Arduino code we set pin mode, then we start the number, that will be 2, and what we're going to be doing with that pin mode. Either it's going to be an output or an input. If we say an output, we write output in capital letter, so it's going to be output. Now, let's say that pin 3 is going to be an input, meaning that it's going to be testing the field to see what the signal is, whether it's a 5 volt or it's not. That's the idea of reading a signal. But let's say that 3 is going to be an input. Then we said pin mode 3 is going to be an input. As always, we close that to ensure that it works. So that everything is done within the voice setup. Voice setup is important to have the proper settings of how the input, or which of the pin will be input and which of the pin will be output. Now, let's apply an example, a good example of the industry that this has a lot of relevance, and it's going to be like this. For example, last Friday, we were discussing something about a tank. And in that tank, we're going to have let's say we're going to have 2 level sensors that looks like this, and those level sensors are magnetic in essence. A magnetic sensor basically on this particular scenario looks more like this, like a switch. Like a switch. That's a switch. What's going to happen is, if you impose to that particular switch, for example, a magnetic field, to that switch, it closes. So how that happens in this type of sensors, which are called level sensor? Well, what happened is that there is a float. If I draw this a little bit better, the switch look like this, and actually all this is in an enclosed, it is enclosed like shown here, but then here there is something that can pivot, and there is a magnet inside here. Alright, and that magnet pivot right here. See? So if the magnetic field is very off from the switch, and this basically is like they call it sometimes, this type of switch they call it reed switch. Reed switch. If the magnetic field is very far from the reed switch, it stay open. Open meaning it's open. There's not a path for the current to go through. So it is open. So if I'm reading for example, the resistance is infinite. There's nothing. Now, when the levels start to rise, what's going to happen is that this part, which is a float, remember the magnet is within a float. That's a float. Has a density below water density. So it will, when you put this on water and the water start to rise in a tank, for example, now you will have something similar to that, but these here are the wires, right? There's no positive or negative on the wire. It's just a path for the current to go through. So these are not polarized, right? They are not polarized. Now, what's going to happen is when water starts to rise, this will level off the float part, and now the magnet will impose its field to the reed switch and the contact will stick together. Remember, this is the pivot area here. What's going to happen is that when the magnet get into the field of this, then the contact, the reed switch will close, meaning that there's a path for the current to go through. Again, this is because the water level is high enough that will force the float part to get into the magnetic field into the reed switch. So this is basically how this level switch work. They're kind of nice and very cheap as well. All right, I have a level sensor in my hand right now, and this level sensor here, inside this part here, there's a kind of a reed switch, or sort of like a contact, two metals, and when those two metals are aligned with a magnet which is in the float here of the level sensor, and when they are aligned, notice that there's a sort of like a hinge right here, and that hinge only have one position. If you install this way in a vessel, when the water level rises, it will align the contact and with the magnet, and therefore you have a short circuit between the two terminals right here. Those two terminals will then be used, indicating that there's a short circuit. All right, so depending on whether you install this very high on the vessel, that will be a high level. If you install low in the vessel, that will be a low level indication. If you install multiple of them within a vessel, then you can have a profile of what is the liquid content within the vessel. Let's do a quick test here, and again, let's see what happened. Let's put this multimeter to measure ohms. Now, if I get the terminals, right now it's reading open loop 0 ohms, meaning that it's short circuit. Obviously, I'm touching the terminals of the multimeters. So let's do very quickly. Let's see. I got an alligator here to get this right here, and then from there go to the terminal. Let's say it's gonna be the black one here. It doesn't matter, it's not polarized. And then the other one, which is the red one, will go to the other terminal within the cable. It's right here. Now I can leave it like this, but it's gonna, as soon as I start to mess around with the level, it will disconnect. So let's put something quickly here that it will stay the way we want it, and it will not move from there. Okay, that will do. So now I have both terminals of the level sensor connected to the multimeter, so now I can check. Like for example, right now, open, the contact is open, and therefore it's reading basically open loop resistance or infinite resistance. If I close the contact, you read 0. Open the contact, open loop. Now remember again, this only pivot, the float only pivot within the hinge. So I can install this like this or like this. If I install the float, this float level like this, it's gonna be what we call normally open. So the water, when the water level or the liquid level rises, it will close the contact, indicating that the water or the level or the liquid is right at this level, whatever distance you install this within the vessel. Now, the second way that you can install this is like this. You install it like this. This is what we call normally closed. So when the water rises, it will pop open, and then you have an open loop condition. Installing like this is not gonna, sideways is not the point. It's not, it's not making any sense. So either go like this, normally open, or like this, normally closed. Those are the two positions that you basically install this. Remember, I'm not talking about voltage, because some people get confused and they quickly jump to say that if you have a circuit like that, that would be 0 volt, and when it closes, then you have 5 volts or something, whatever voltage you are using in your system. The answer is no. So that will depend on whether you have a pull-up or a pull-down resistor in order to talk about voltage. The only thing that you can talk right now when you have a switch like this is either in the open stage or in the closed stage. That's it. So the idea is that we're going to have 2 of those level sensors in a vessel, and we're going to call this switch 1, and this we're going to call this switch 2. Switch 1 is to detect low level. So switch 1 will detect low level, and switch 2 will detect high level. So how this will work? How are we going to get all this information into the Arduino? Well, let's work this way. Let's work the problem. So we have a vessel again, and we have switch 1 here and switch 2 here. And what's going to happen is that we have a pump, and the pump will feed liquid or solvent into a vessel. So what is the scenario? The scenario is as follows. If switch 1 is open and switch 2 is open, meaning that the vessel is empty. So if I do a truth table, it's a table of the concept, how we want this to work. In a truth table, I have the 2 switches, switch 1, switch 2, and what is going to be the output? And the output meaning if the pump need to be on, you want to start the pump or not. So like for example, if switch 1 is open and switch 2 is open, what we want to do? Start the pump, right? We're going to start the pump. So pump on. Now, in the order that this will go, the most logic path to this is that water will start to, or the fluid will start to get into the vessel, and this switch will close, right? So switch 1 will be closed, but what's going to happen with switch 2 will still stay open. Do you want to shut off the pump? No, we want the pump to be on, right? So pump will stay on. Now, what's going to happen if we keep adding water into the vessel? Eventually, the two switches will stay closed. When they are both closed, meaning that the pump should be off. Pump should be sent to the off state. Now, let's say that we are using this vessel to push water to someplace else eventually, or do something else. And this is the story. We want to control this pump action with in relationship with the vessel. So the idea is, what we're gonna do if the liquid or the level in this vessel start to drop. Let's say that switch 1, it is closed, but switch 2 now is open. What are we going to do with the pump? Do we want to start the pump or not? Remember, now the level is dropping. If the level goes down, this switch will open. Now, under that condition, we have a condition that is called close open should turn the pump. But we want to do that here. It's the same as this one. Do you want to turn it on? I hear some people saying yes, and the answer is no. We don't want to turn it on. You know why? Because as soon as the levels start to drop and this switch will get into the open state, this pump will start, and it will be quickly on and off. It will be oscillating between the on and off state, and it will burn the pump. So you don't want this pump to be on the on off state. De esta bomba, this pump. Yeah, because actually all this pump is controlled by somebody else. It is this pump that is going to be controlled by the logic of these two switches. So we want to control this pump with those logic. This pump is the one that I'm talking. This one, the first one, not of the second. No. So based on that, we really, although these are identical, we want pump off. See? Now, if open, what we want with the pump? Now we want it on. Turn pump on. Pump on. So this is the truth table of how we want this pump to operate based on this logic. So careful. This part here, the first part, is when you are filling the vessel, so the level is going up. This part here, this section is when the level is dropping. So you want to be careful. One thing is when you are filling the vessel, and the other is when the level is going down. Actually, for this pump, well, what's going to happen? This pump is controlled by somebody else. There's a lot of logic behind. I'm having put in the whole picture together. But this pump is controlled by somebody else, not by by the logic of these two switches. I'm only concerned with the input pump. This pump, input. Let's call input pump. Only by the input pump, not the output pump. So our task is to build the hardware to make this happen, but also to put the code behind this so this works. For this, we're going to be using the Arduino. Okay? The Arduino, we have to define inputs and output. Input are things like this, like the level switches. These level switches, switch 1 and 2, are inputs. Because why we call it input from the Arduino? Because the Arduino It's the computer, and the Arduino will be receiving the information from the field. For example, this is the Arduino. So we need to identify two pins in the Arduino. Let's say, whoops. Let's say pin 2 and pin 3 will be the input for the Arduino. Meaning, they're going to be testing, checking what is the position of those switches, whether they are open or whether they are closed. So meaning that's an input, because that information is coming for what I call the field. The field, in Spanish we call it campo, el campo, but not where the cow is eating grass. No, I'm not referring to that type of field. Or the football field, no. It's what is on the control of the Arduino. That's what we call the field. In this case, there's going to be information arriving into this, into the Arduino. Now, the Arduino then will analyze the position of those switches and will take, based on code, what we're going to be doing in terms of what we call output. Whether the Arduino will output something to the field will depend on the logic between 2 and 3 of those two pins, right? So this pin number, let's see, 2, 3, 4. Pin number 4 for this scenario will be an output. Clear? So I'm doing what is called pretty much the design, the hardware design. How the hardware design will go. We have two inputs, two level inputs, and we have an output, 4. Jamil, are you clear? Good. How are we going to do those inputs? Very simple. In the Arduino, there's two types of input design that you can easily put together. One of them is called pull-up. Let me change pages here. One of them is called pull-up resistor or pull down resistor. Either of them will work for what we want in how to let or use the Arduino input, to check whether the switches are done or not. They're open or they're closed. So let's work with the pull-up resistor. How we set the pull-up resistor? The pull-up resistor basically set like follow. I want to have 5 volts, a resistor, a point, and a switch. There we go. This resistor is going to be a 10 kilo ohms resistor. And this is the line, or the wire, that eventually will go to the Arduino. To the Arduino that are declared as inputs. In the pin mode, you have to declare pin at this point. Pin 2 and pin 3 are, let's write that down here. Switch 1 will go to pin 2. Switch 2 will go to pin 3. And the output pin for the pump will be pin 4. Meaning that pin 4 is an output, because with pin 4, when pin 4 you set pin 4 to 5 volts, you want to start the pump. Now, pin 2 and pin 3 you are reading the status of those pins. You are reading, meaning that these pins here, both of them are declared as inputs. All right. So this switch could be any switch. Could be switch 1, switch 2. It doesn't matter. Let's say that I put this on switch 1. If switch 1 is open, what's going to happen is I'm going to detect the volt that I'm using, the voltage that I'm using at the top here, because this is called a pull up. The voltage at this point, and this is the line or the wire that goes to the Arduino. Let's say, since this is called switch 1 needs to go to pin 2. This is going to pin 2. What's going to happen is this. This is the switch status, and this is the voltage that I'm going to be reading at the Arduino. For example, if switch 1 is open, the voltage at the Arduino will be 5 volts. Because if this is open, the voltage here will be the same as this one. That's what I call it, a pull up. This resistor will bring this wire into 5 volts. Now, on the other hand, if the switch is mated, it is closed for, because the magnetic field closed it. If it's closed, what's going to happen is we're going to get 0 volts. That's what's going to happen. We got 0 volts. All right. That's for this diagram here. Is what we call a pull-up resistor. Now, there's another configuration, which is called the pull-down. In the pull-down, it looks similar, except that the resistor is closer to ground, and this is a 10K, but here I have the 5 volts, and this is the switch, and this go again. This switch could be again the switch 1, could be any switch, anything that can that you can operate between 0 and 5 volts. I mean, between open and close. That's what I mean. Anything that you can operate between open and close can be installed into the Arduino as an input signal, and you will take decision based on that. For example, in this particular case, again, this will go to pin 2, and there's a truth table. The truth table for this switch 1 voltage. If the switch is open, check this out. If the switch is open, now this pin 2 is driven to ground. It's forced to 0. So you have 0 voltage. But when you close the switch, different. When the switch is in the closed state, then we have 5 volts. In other words, one thing is the position of the switch, whether it's closed or open. Another thing is the voltage. To determine the voltage, you have to first of all understand that there's a configuration required. You have to decide whether you're going to be using pull down or pull up. Which of the two you will use? Remember that a switch is a switch. It's only open or closed. That's it. There's no voltage. The voltage show up after you determine if you're going to be using the switch in a pull up or a pull down configuration. Which one you're going to use? Both will work. It's more about convenience. What's more convenient? I would say some cases maybe the pull up, some cases the pull down. In most cases, I would say maybe the pull down maybe is better. Maybe I don't know. Again, they have to be analyzed case by case. Let's design this project using pull down. If I'm going to be using pull down for this project, in where I have my tank and the 2 switches, look like this design. First of all, I haven't said something very important about these switches. These switches, the way we're going to put them in the vessel, they are normally open. That's one important part. These switches, they have a state. We call it normally open. So the contact is in the open stage. The open stage. That's the important thing. I forgot to tell you about that. So these switches has either they are normally closed or they're normally open. The one we're going to be using when we install this guy in the vessel, they will look like this. Remember, these are the wires, the wire connector for the reed switch, and the magnet will be like this. This is the magnet here. Now, in this position, the magnet field is very far away from the reed switch, so the reed switch will be in the open state. That's what we said, that this design is on the normally open condition. This is what we call it a normally open switch. On the other hand, see, if I'm talking about normally open, it must be normally closed as well. What happens in a normally closed switch, it looks like this. Again, this is the reed switch. These are the wires sticking out, but the guy will pivot here on this point, meaning that this guy can go up that way. This guy can go up that way, right? So here's the magnet. Now, the reed switch is right at the magnet field in a normally closed state. This is a normally closed position. When the level go up, you know, when there's some water here, it will push the magnet out of the field, the magnet field out, and the switch will open. But in this position, this switch is closed. That's what we call it, normally closed switch. If you put the level switch, this level switch in this position like this, where this guy can pivot up, the magnet can pivot up, meaning in most cases it's going to be normally closed. The other one, if this can pivot this way, the only way that this can go is up, because that's how it was, you put them in within the vessel. So normally open, normally closed. These guys, these two switches, switch 1 and switch 2, are normally open switches. Now we're going to configure them on the pull-down resistor. Pull down, meaning our design will be like this. This is going to be switch 1 going to pin 2, and here is the switch. This is going to go to 5 volts. And this is a 10K resistor. So we have a 10K resistor, and in most cases, this is normally open. Unless there's water rising in the vessel that closes the switch. If the switch is closed, then the pin 2 will change from 0 volt to 5 volt. 5 volt meaning, in this case, 5 volt means that the switch was closed. See? All right. So we're going to be doing the same for the other switch as well. It's the same. Don't try to configure one switch up like pull down and the other pull up, because if you messed up too much with this, you're going to get confused on the status. Right now, when the switch is closed, I get 5 volt. That's all what it means. When this switch closed, you get 5 volt. If the switch open, you get 0 volt. That's good enough for me. That's the true table that I'm getting from this switch. Is switch 1 and voltage here. Voltage at pin 2. If the switch is open, I get 0 volts. If the switch is closed, I get 5 volts. That's good enough for me, because I'm going to design the second switch the same. It's going to be the 5 volt here, the switch, the resistor, and from here, from this switch, I'm going to have this coming this way here, and this is going to be switch, let's put a number here, this is switch 1 and this is switch 2. Alright, so what's going to happen now is this is the one that will go, this switch 2 will go to pin 3, which eventually will have the same truth table. This is the switch 2 and this is the voltage. So if the switch is open, I mean, you can see clearly if it's open, the only thing that is going to arrive to switch 2 is 0 volts, nothing. Now, but if it's closed, now you get the 5 volt. So we're going to configure both switches on the pull down configuration. You can use anything. Remember, you can use anything. When we talk about voltage, we already go through this, thinking what type of a scenario that we're going to be using, either pull up or pull down. We're going to be using pull down. Be sure that you understand the differences between both of them so that you can, decide which one to use. Right. We are in perfect shape. So we know that we want pull down. We configure. This is the hardware that we're going to be building in the Arduino using Tinkercad. Just to understand what we have in Tinkercad, just ensure what confuse sometimes a little bit are the switches within the Arduino. What type of switches that we're going to have? They are push button. They are the type of push or permanent. Push button, you have to push or press the switch so the switch will close, whatever that means. Because I'm talking about voltage, please do not talk about voltage. Voltage has nothing to do with the state of the switch. The voltage will come after you decide whether you're going to be using pull down or pull up resistor. You understand? People get confused, meaning that as soon as I push the button, I see 5 volts. I will see 5 volts. Not necessarily. Not necessarily. Right? Get that straight. So what we're going to use, a permanent, meaning that I will activate the switch and it will stay there. If I want to deactivate the switch, I move it again and it will deactivate. Push buttons are bad in the sense that they will not work for our level sensors. Our level sensor, when they engage, they will stay there unless the condition disappears. A push button is basically you have to stay with your finger into the push button to maintain the push button engaged. In the particular case that this push button is normally open, when you push, it will engage. That's the condition. So we're going to be using permanent, a type of push button in the Arduino that is easy to work. You put it in or you set it, you activate that permanent switch and it will work. Perfect. All right, so let's talk about the code a little bit, how the code will behave on all this mess. Very simple. Let's say that the first thing that we're going to be doing is the void setup. Void setup. And then we define the pin modes. So we're going to set pin mode. I said the 2 is going to be an input. And then let's make a comment. Pin mode is an input for what? For what switch? No. Switch number 1. And switch number 1 is for what? Is the low level or the high level? Low level. That's important. You see, I put a comment. A comment, this you use this forward slash for two forward slash to create a comment. So I know that pin 2 is going to be for switch 1 low level sensor. Now pin mode 3 is going to be an input for whom? High level. Good. Just to be sure that we get this straight, I don't like to put this bracket here. I prefer to put that bracket. Let me see. Let me erase this. I prefer to put that bracket. Looks better. Oops. Let me get this. Oh, you got it. I prefer to put the bracket here, the open bracket, and then I'm gonna be adding another pin mode because I'm using for the palm. It's gonna be 4, right? 4. On the other hand, is an output. And we're gonna call this output or palm on / off. Right? That will do. We close the bracket, and that will do for the voice setup. So we define the 3 pins that we're going to be using our Arduino and their input, status, or output. Now, the next part is the void loop. Open the bracket again. Now, this is the part that we're gonna. This is we need to analyze this in a little bit. I don't know. Let's see. Let's work together this. The first thing is checking the status of the switches. We're gonna be reading those switches. There's an instruction, as we talked last class. There's an instruction to read the switches or to read the pins. Actually, the Arduino don't care about the about the switches. It's just care about the pin. If the pin happen to be high or low, then you do accordingly. For example, let's say if read, if digital read, like the R, capital R, digital read, what we're gonna be reading? Digital read, I don't know, which pin? First pin, 2. That's a low, right? I mean, sorry, that's for the low level. Yes. Digital read 2 equal. Check the way that we write in Arduino the equal. It's 2 equal signs, not 1, because we are doing a comparison. We are comparing the content of this pin on 2 with what? Whether it's low or high. Let's say the action will be taken if it's low, right? So let's say equal low. But there's 2 things here. There's 2 comparison, 2 digital switches that we need to compare, and as well to ensure that is in the low state. So let's write, let's put another bracket, another parenthesis here, and close here with another parenthesis, and use the AND command. Those AND, I don't know, ampersand, I think that they call it. No, it's not number. I think that is the one that is in top of, I don't know, let's see. About, that's the symbol that is over the 7 on your keyboard. Put 2 of them and do again a comparison and say if digital read now 3. What I'm looking here, remember, I should bring the I think that we need the truth table. Let me go back here for 1 second and let me bring the truth table. Let's see where it was. I need this because it's against this table that I need to do what I need to do. All right, so let me put this somewhere here. All right, let's see. Let's get it up. Uh, all right, there we go. If data read 2, which is about the status of this switch, is low, meaning since I'm using a pull down is going to be it's meaning that it's open. Remember, if the switch closed, then you get the 5 volts, and that would be high. But the issue here is that both need to be open. So digital read 2 equal low and digital read 3 equal low. Close the parenthesis there. Then what we're gonna do? What we're gonna do is do a digital write, because that's when we want to start the pump, right? So we're gonna do a digital write to pin, which pin? Pin 4. Pin 4, and we're gonna do a high. We close the bracket. Remember, this need to close with that. And now that's basically we'll do the first line, this line. The second line, we're gonna test for this line, and we're gonna do if digital read to equal high and digital read 3 equal low, what we're gonna do is the same, keep the pump on. So meaning that I can write here digital write 4 in high position. For the Arduino, for the programming that we're gonna do, that high will go to a LED, to a LED. Let's see. Yes, here, right here. That's correct. Let me see. I got this. Yep. Perfect. Because if I don't close it, you know what that means. 2.5 there. What's up? See, no, you have to put it in, because otherwise the Arduino code will detect that I'm missing a parenthesis right there. Now, so basically that's what we have. Digital write 4 high, so we close here. No problem there. I can end this with the same line, saying something like if digital read 2 equal high, and digital read 3 equal high, what's going to happen? Then, in that particular scenario, I want to shut the pump. Digital write for low. Check always that you end the sentence, the way it should be. So digital, there we are, right. The W is capital W, low. Close this guy. All right, so up to there, we have the proper order of this. It's going up, up, so it's filling, and it makes sense. So, like, if both of them, of the digital switcher, are in the low state, we're gonna put the pump on. If the low level goes into high state, but the other one stay in the low, we still want to pump on. Now, when both are high, then the vessel is full, and we want to shut the pump. Perfect. All this action here to fill the vessel. All that action there will fill the vessel. That's all. Now, let's say what's going to happen when we have the following instruction. Now we're going down. In the order of things, the switch 2 is the one that will open first, because the level will start to drop, meaning that if parenthesis digital read 2 will stay high, this one will stay high, and digital read 3 equal low. What we're going to do on that case? Shut the pump off. And I tell you, this is going to be a problem. But we're going to write this down, and we're going to say digital write for low. Why is going to be a problem, that instruction? Because the Arduino code, the way it works, let me see if I can put this all together here. When the void loop starts to operate, it will go through each one of them one by one. And in one point in time, it's going to detect this digital read high, but another low, and it will start to turn on the pump. But on the other hand, it will detect this one, and we shut it off. See, because it's the same conditions. You know what I'm saying? Milaris. They will fight each other. That's a bad design. This is the bad code. Because you turn it on this instruction here, on this one, you turn the pump on, but since I have the same conditions here, on this line here, but I turn it off. I send a signal to turn the pump off. That's bad. Bad design. Okay? There's something that needs to be done here to understand why our code will fail. Although it makes sense when we write it down, but during execution, they both of them will fight each other. One will turn the pump high, and the other will very quickly, like few microseconds later, will turn it off. So the pump might receive. The pump are not that fast, so probably might stay off. But that's not a good design at all. Not good. because the problem here is that one thing is filling the vessel, getting the water into the vessel, the system will go in the up position. But another is when it start to, you start to use the water within the vessel, and it's going to get emptied, and in that principle, you're going down. So it's like this old saying that we have in la fiesta de San Sebastián. In the party of San Sebastián, either you are going up or you are going down. You remember that? Voy subiendo o voy bajando. That's the way this works. So you gotta make a difference between in what actual state you are. What the hell are you doing? Before getting into that, let's open Tinkercad and let's start to work on the design and all the aspect of this, and start doing the code programming, and let's see how this will work. So stay tuned for the second part of this. We go now to Tinkercad. Alright, so here we are for the time level design. We are in a simulated environment. We are using Tinkercad for this. And the first thing, let's bring an Arduino. We put an Arduino here somewhere. Let's put it here. I like to turn it around. And now let's bring a small breadboard. This is what we call it, the field. We're going to put the field right here. We're going to turn that one as well. And what else? That looks good. So the question is, what type of a switch that we're going to use? Push button or permanent switch? I said, don't use push button for this. Don't use push button. Push button might be used for only one switch. We have two switches here. So we'd rather we can do a slide switch like this one here. That will do. Or we can use, let's see. Let's go into put all. Thing that we can use in terms of switches. Maybe we can use deep switch as well. Or we can use this guy as well. Deep switcher, for example, this one has about 4 switches, or this one has about 6 switches. So which one you're gonna use, it depends how complex your what you setup you have in mind. I will use, I don't know, let's see, which one will be better? I'm gonna use slide switch. So I'm gonna be using 2 slide switch to simulate the concept here. Now let me bring an instrument so that we understand what is happening here. Let me bring an instrument like a multimeter. Just a second here. And let me open this big. Whoops. Alright. So check this out. For example, notice that the switches has a position already. These switches come within a position. Between terminal 1 and the common, that will be in a closed position. That contact is done. So that means if I use those two, it means that my switches are normally closed. But my switches, I said, they are normally open. You have to push them to activate them. What that means? It means that are the terminal 2 and the common are the one that we're going to be using for our switch design. Because these switches come with 2 scenarios. What you're going to be using? Normally closed or normally open? Well, in my case, it's normally open. Remember that? We said that it's going to be normally open. Professor, how this work? Oh, very simple. Like for example, connect the cable here to here and connect the common to here, to the instrument. All right? A sensor, a switch without a battery or anything, the only thing that this instrument can do is to read what? What this instrument can read. If there's no battery, there's nothing. Resistance. That's it. Change it to resistance. From voltage, put resistance. Now, let's do the simulation. Start simulation. See? It went through and is reading mega ohms, meaning that that switch is open. If I, if I close the contact because the level start to increase, it means that this switch, when you move the switch, then the resistance drop to 0, meaning that the contact is done. See how easy it is to understand this? Put it back, it's open. Put it down, it's closed. That's it. Nothing, no more complicated than that. It's just you have to pay attention to those little characteristics that when something is called normally open, what it really means versus when it's normally closed. It means what you're seeing here. If I leave it like that and move out of the simulation, stop the simulation, it will stay there. See? So, start simulation, it will start like it's closed. The contact is closed, but normally it's here. When you bring the switch, it's normally there. So, nothing more to say. Stop simulation. Now, get the instrument out. We're not going to use the instrument here. And what we want to really do, it put the instrument in, the sensor or the switch, these switches in such a way that looks good. Let's let me turn it around. And let's say that I'm going to put, this is going to be the top sensor. And let's switch this as well. And let's say that this is going to be the bottom switch. Alright? We got the top switch and the bottom switch. This is switch number, this is number 1, which is the low level. This switch is for low level. If I want to write something down, let's see if I can write something down here. I can put there low, let's see, low level. Oopa. Switch. And then you can move it around. Let's see if I can move it around. Can I? Yeah, here we go. Oh, right here. There's a cloud here. I don't know, this one or this one. I think that I use this one. And then put it right here. And then write on this one, step in and just write high level switch. And there we go. All right, that's perfect. So we got the switch. Now the issue is it's going to be a pull down. In a pull down, basically what we have is there should be a resistor somewhere here. Let's call it a resistor, and let's move that resistor around so it looks better. And one of the legs of the switch has to be to ground, meaning negative here. And that resistor is a 10K. So switch it to 10K, 10 kilo ohms. Perfect. Now, what's going to happen now is that the other leg, this one here, that's the one, let's see, that need to go to 5 volts. This leg needs to go to 5 volts. So write that down to 5 volts, put it here. And we're going to switch that to red so it looks better. And the switch is almost done. Again, from where I'm going to get the 5 volts? The Arduino is kind of nice. It knows that some of the instruments out there need power, permanent 5 volts. So the Arduino has a special pin for providing that voltage to us, to the breadboard. So we get this here, and now to the positive, all that line has 5 volts now. So let's understand what's happening. If I run this code right now, and I want to check something, let's bring an instrument now that we are in this. This is the nice things about this. You can test different things as you go along. Let's say the multimeter is right there. Now, before doing any testing, let me get the ground cable where it should go. This is ground. Should be, let's put it here, ground. And let's change the color to black. Alright, so we have positive and negative into the rails. Positive rails and negative rail. See? So the resistor is right at the negative rail because it's a pull down. Now, where I should read the 5 volt from here? Check this out. Gonna put it right here. And this negative will go to negative here. Let's get this on. I'm gonna get this in another color. Let's put it red in the meantime. Now there's voltage here, so this guy, the instrument, need to read voltage, and it's right at the voltage. If I don't check it out, voltage, good. This is the story. I'm not using the top part, I'm using the bottom part because I'm simulating what we call it a normally open. Normally open, meaning if I run this, I should see 0 volt now here at the instrument. Let's see if that's true happen. If not, we need to fix. Start simulation. There's no code, there's nothing on the Arduino, I don't care at this point. I'm only testing the hardware part. Professor, it's 0 volt. Well, that's perfect. That's what's supposed to be because it's in the open stage. If I close the switch because the water start to rising, if I don't see the 5 volt, we're in trouble. Now I see the 5 volts. Oh, it's perfect. We are in good shape. Up to there. Are we all aboard here? Good. So we are right on. Now, let's do something else here. Let's get, I'm going to leave the instrument there for the time being. Let's work on actually the pin, the testing pin is going to be from here. This is high. High was for which of the pin? 3? 3. Okay, so let's stop the simulation so I get this right. So it's going to be 3 for the high. And we're going to get that pin right here. Let's do this. Does look good. That's okay. All right. You have more time. You can do it better. The wiring and all that. I'm trying to get this done within the time that we have. So now pin 3, the instrument is reading 5 volt. It means that if I'm reading pin 3, there should be 5 volt as well here, arriving when this is connected. Right now it's in the connected state. I leave it there. You know, I should start the simulation. I should see the 5 volt, but if I drop this to where it's supposed to be, it's going to be 0 volt. That's the way it is because it's normally open. So stop simulation, and we are okay. Now change this color. 2 is an input. What's the color for input? For input or output? Well, let's say purple for input because I think it's blue for output. All right, good. So that's an input, and let's work on the connector on the low level switch. In the low level switch, it's the same. Copy this resistance, copy, paste, and move it to where it's supposed to be. And I don't like it here because it's creating me a problem with this. The other, well, not that it's not problem, but you know, I don't like it the way it looks like now. So get this negative someplace else. Get it here, and that would do better. Now the other pins go to positive, so let's get this here to here, and let's change the color to red. And now pin 2, we need to do a trick here. Get it up here, get it up here, and get it right there. Change the color to purple as well. And now we have that, and it's identical to the one at the top right here. If I want to check that everything works, get this out of here, or just to test the other line, just to be sure that there's not screwed up. So you test the voltage here, and change that to red. And I know that I'm reading voltage, so start simulation. And let's see if I close this switch. Perfect. I get the low level. Again, the configuration that I have here is what we call it pull-down resistor, because kind of makes more sense. If the switch is closed, we are always, our mind is kind of built in that way, because we are used to electricity. When we turn on an interrupter, the light turn on. See what I'm saying? It's like a meme one time I read at one point in time that said Al Pacino was talking in one of the movies. I said, oh my God, if I turn interrupter here, something turn on back somewhere there. So something like amazing. But that's basically what it is. It's kind of amazing the way this works. So let's turn this guy back to where it's supposed to be. And now, basically, the hardware is pretty much done except for the LED. We need pin 4 to do something for us. Let's turn the LED. The LED, I can put a motor here, but I don't want to do that. I want a very simple hardware design. So let's build a LED. Let's bring a LED here. Where's the LED? Right here. Put some LED here. And I also, let's twist this guy around. You can put the LED anywhere you want. Let's put it here. Now I need a resistor. 5 volts. 5 volt, basically 150 ohm will work. You can put the resistor, like for example, this light will be the positive, so I want to use it right here to the negative, and that guy will be 150 ohm. And the positive from here will come from pin 4. There we go. Alright, so let's see. Resistance 150 ohm. Be sure that you check the last name of the resistor, because if you leave it in any other wrong unit here, this is gonna get screwed up very badly. So 150 ohms. So we got the low level, the switch level, and the LED. Let's change color here. Red is bad for this. Let's put the blue output, purple, or whatever it is. What was that? Purple input. Some coding. If that's the official coding, no, not at all. Your company will eventually have the official coding, how they want to call them up. If they want to call it a certain way, but they do that, all right. So I think the hardware point of view, we are ready. So let's go to the code. I only have one Arduino. If I had like a 3 or 4 Arduino here, you have to identify which one you are using. So typically you have, let's say, 3 Arduino, you step into one. When you see this one here, then you go to code. Because if you have 2 Arduino, you have to identify which one will have which code you are working on. I'm working on the code on the only Arduino that I have, which is Arduino 1. So go code, go here on the say text, yes, continue. As always, we have a little bit of a code here, just to give you an idea, a flavor of the type of code that is used in the Arduino, which is a type of C code, not a big deal. And straightforward, pretty much English style. So pin mode. Pin mode. It's gonna be 4 is the output, right, Pablo? Is that true? 4 is output. So copy that. Put that in there, and we said that it's gonna be, I think it was 2, but that 2 is input because it's gonna be reading the field input. And then the next one, pin mode, that's 3, and that's input as well. Oopa. All right, so I have already the definition of the pin modes. So I let the Arduino knows what's going to be input and what are going to be output. Novoa, are we okay here? Good. Now, here's where the mess will start. Because remember that the loop is what the Arduino will be doing for the next 100 years, as long as there's power into the unit. So the voice setup is executed only one time at the first run of the Arduino. But then the second run, the third run, and everybody else will be on the loop. So the loop is the one that will stay forever. Until forever hold your peace, right? That's what they said. Yeah. Talk now or forever hold your peace. So, meaning, now we are in the loop. What we're going to do here? All right. So let's start working on this. I'm going to push this. Actually, I'm going to delete all this. I don't want to get all confused. And so let's see. If check, I'm using capital letters. That's bad. You see, no, there is no color change, and that's not good. So get that. If now there's color change, that means that that's the right instruction. If digital read, I think that was help me here. What was that? 2. If digital read 2, but this I'm missing something here. If digital read 2 equal high, no, low. And which is the stuff over the 7 in your keyboard. Open another parenthesis, and what is going to be digital read. Whoopa. Digital read 3 equal low another parenthesis, and then here we take the action. The action is digital write. We're going to write to the pin 4, and it's going to be on an output state, meaning that the LED will turn on. All right. That's basically it. We close this guy. And now we check again. I'm going to copy all these. I don't know. I think copy and put it here somewhere, and then change what I need to change. If digital read equal high, and digital read equal low, stay the pump on. You know, lead for high. Good. Actually, I put output here. Nobody correct me. What should I say here? High. Yeah, pay attention. You know, stay on the ball. You don't want to get hit. High. There we go. Now, copy. Third one. If digital read 2 equal high and digital read 3 equal high. If both high, then we want to turn off the pump. This should be low. That's perfect. Let's call this part here. Let's make a comment. The comment is going to be you know, this is the feeling of the tank getting, getting water, or you are feeling the vessel or the level going up. This is the direction is what I call level going up. Oopa. Level, oopa. Level going up. All right, so that instruction there, what follows after the level going up, this is a comment. It's just that I know that these instruction in this section here are for the level going up. Now, I have to start to think about when the level is going down. Something needs to be done, because I know that they're going to be fighting each other, and it's not going to be good. I'm going to write it anyway bad, then we fix it. We're going to fix it. Level going down. Level going down, meaning, let's see which one is that. After I shut the pump off, it's supposed that the digital read 3, which is the switch, switch number 2, if that open, so I have this condition. It's identical to this condition. Copy, paste, but on this case, I don't want the pump to turn on. It has to be off. So this is low. And what's the final thing that's going to happen? If I have a low, then we go back. But that's taking care. I can write it here. But that's basically taken care by this going up again, because it will detect it. If you are in the low, if they are both open, the both switches are open, low, you are going up. See what I'm saying? So maybe this is the only one that need to be you have to think about it. How can I make this, the Arduino, understand when I'm filling up or the vessel is getting emptied? You have to think about those terms, because I see a problem here. This last bracket here, this last one, this one here is with this first one. Remember that this loop, the void loop, has an starting bracket and an end bracket. Everything in the middle is what I want to be executed forever. Well, let's see how many mistakes I have, how many things I have left. Sometimes happen. Maybe I haven't left anything. We'll see. The easy way to do that is start simulation. Let's see what happens. Start simulation. If I miss something, it will let me know. Oops, everything run perfect. I know that the code is not good, but at this point, it seems like everything's okay. And the LED is on. Why is on, Pablo? It's a mistake, or the code asked for that? But that would be bad, because it should be on. Should be on, because check the position of the switches. They are open. Both of them are open. See what I'm saying? They are both open. So the LED should be on, meaning I need to put water into this vessel. The first one that I need to close is this guy, the low level. If I close the low level, the LED should stay on. If I close the top one, the LED should go in the off stage. There we go. Perfect. Up to there, filling the vessel, everything works as a charm. The problem is going to be now. Let's say that the vessel is fully up, fully to the top. As soon as you start to pull water out of that vessel, the high level will disengage. meaning that this will go to the open state. And now you see the LED is kind of flashing, although it's kind of hard to see it, but the LED is flashing. Because in one point it's being sent to off, but in another it's sent to on. So that's not good. That's a bad design. It's a bad design. There's a problem here. To start, the punch should not start when you are going down until you have both switches in open stage. Yamil, makes sense to you? There's a problem in the code. How to fix this issue? Let's stop here. So I want to be sure that everybody's up to here until we go to the third and last recording of this class. Alright, so this is the last recording of this class, and let's see if we figured out the mess. And we were talking about that we have a problem, and let's go back to what is the actual problem. Start simulation, and let's go here, and here's the problem. The problem is, let's say that let's see where we are here. Alright, so this switch is open, and this is where this one, the low level and the high level, they are both in the open stage. It's supposed that the pump be on, and that's perfect. That's working the way it should be. This is how the thing will look like when you start. The next thing will happen is that the low level switch will close because the level is rising. Good. And the pump should stay on. That's perfect. Working as a charm. The next thing is when the high level close, the pump should go off. Perfect. We are right on the money on that 3 stages. The problem is that if we start to pull water from this vessel, the high level switch will click open and the pump will start, and that's not good, because the pump, as you know, as soon as the water start to go up, it will switch the pump off. But as soon as the water starts to go down, it will open the switch, and then you have a pump that will be starting on and off until it burns out. Not good. Our code has a problem. It doesn't take care of the pump because it's starting off and on and off all very suddenly, too quickly. It will burn the pump. So there's a problem in the code. Thinking about it, stop simulation. We go to the code. And what we talked about was that might be the problem is that we need to identify whether we are going up or down in the vessel. If the level is going up, then it's one thing, but when the level is going down, it's another thing. So let's add a variable here. About, over the void setup, let's put a variable there that says something like, let's say, I don't know, let's write a variable here. Integer, it's going to be an integer variable. Put integer, and let's write here, switch, or let's write, I'm thinking going up. Actually, let's write the word going up. Going up equal 0. Going up equals 0 means that you are not going up, you are going down in any case, right? That's what it means. Going up equals 0 the meaning of that is that you are not going up, you're going down. That's it. Now, if I write that down, the nice thing is that I'm initializing that variable with 0. Alright, it's an integer, and the word is called going up. See, you make the name as you appreciate it to make more meaning to you, so it's more significant to what you're doing. Now, here's the story. If digital read is low, and this 3 is also low, if both are low, it means that this variable going up, underscore has to switch to 1. When you put it in 1, now it means you are going up. And that's the only way you're going up, when both switches are off. Then you're going up. Now, here's the story. When you want this to work, I want this to work when I'm going up. So what about if I add something here? It said, and parentheses, going up equal, not sure, I think it's 1, maybe, equal 1. So in this if statement, I'm asking 3 things. Listen, is the switch that I'm reading on 2 is high? Yes. Is the digital read 3 is low? Yes. But I'm going up. Yes, you are going up. So I want the pump to stay on. See what I'm saying? See where I'm going, Pablo? So because this instruction is the same like the other one, but now it's going to be the difference. Because now here, which is pretty much identical, I'm going to send the pump on the off stage if I'm going down. If I'm going down, but let's be careful here before I jump to conclusion. I'm going here. This makes sense here. I'm sorry I cannot open this bigger on this simulation. So good. This makes sense. Now, this is high. This is high. When both get to the high stage, it meaning the only thing that can happen from there is going down. Then there, I have to say I'm going down. And to let the Arduino know that I'm going down, I'm going to write going up equal to what, Pablo, now? 0. There we go. Now I'm not going up anymore. I'm going down. If that's the case, here I need to identify that position as going down. And the only thing that I need to do is test that condition by saying and going up equal 0. Missing one parenthesis here. I don't know. It has this and this, and I think I'm missing one parenthesis here. I'm not sure. And and now, if then I shut the pump. If I'm going up, but if going up is in 0, it means that I can shut the pump. If I'm going down, the pump will stay off on the off stage. All right. After that, should I have to do anything else? Well, no, not that I think. But now check this if. And this if they're in, I'm testing 3 situations on each on the one that there is a situation that they are common to both sides, to going up, to going down. They are common, and we have to make a difference why and when we're going to shut the pump off, and it's when we are going in the down position. So use another variable to identify that condition based on code. It is the code. I'm not adding anything else to the system to let that it's going up, it's going down. It's just based on the switch's position that they are right now. If they are both off, we're both open, you are going up. But then if they are both at the high stage, they are both closed, meaning that we're going to go down. And that's the thing that I use to switch, whether to add this another switch, to add this new condition. Well, let's test it. Let's see what this work or not. Let's see. Everything looks good. Let's go. Let's close this, and And let me fix this. So there we go. Now both are in what stage now? What stage are here? Pablo, you see it? Where we are now? They are both open. They are both open. Good. The first one that I need to close is this guy. The pump stay open. Good. I mean, the pump stay open. No, the pump stay on. That's what I mean. That's what I mean here. The pump is still running. Perfect. Now, this one should close because the water start to rise until the last level switch off. I mean, or close. There we go. The pump should go to the off stage. Perfect. Now it's in the off stage. Here's the mess. If this piece of code that we added fix this, the next thing that's going to happen is that I start to use water from this vessel, and this guy will open. So let's open him up. Hey, there we go. Stay closed. I mean, the pump stay off stage. So it's working. Now, what's going to happen is that this one will open as well, because the vessel will, drain to get all totally. So the pump should start. If not, the code is bad. Bingo. What I'm doing right now is testing the code. It's called validation. Ensure that the code do what it's supposed to do. We create a truth table. You remember the truth table? The truth table said that if this switch is on, and this is on, or this is open, or this is closed, this is what's going to happen with the output pump. Now it's doing precisely what it's supposed to be. Right now, we are starting again, and the switch, as you can see, the switch are in the open stage, meaning that there's zero voltage getting into the Arduino, and the Arduino, based on code, decided to turn on the pump. Going back to the code, stop simulation, and here go to the code. So we test the code and everything worked as supposed to. Now, will this be the final version of this code? Actually not. Maybe we can make it more simple, or do simplification out of it, but at this stage it works. Sometimes that's what we want, that a code works. And this is doing great so far. By just adding this internal variable so that we let the Arduino know when the system is going up or going down. So that did the trick here. Basically, there's nothing else that I need to add to this recording, so I'm going to stop here. And that's basically it. Have a good time.